The software and the servo never know what size cog you have on the end of your motor shaft. So you could have a cog that's 5 foot in diameter. You could have one that's 5 inches in diameter. It literally has zero clue of that. And when you're in this calibration mode, you're giving your servo the data that is needed to perform the calculation. So what that calculation simply looks like is I traveled X amount of distance and it was X amount of pulse codes. And that then builds a relationship to it's X amount of pulse codes per inch. So essentially that conversion is just made like a distance type of conversion in the same way that we say it traveled 60 miles per hour. And so now that servo system knows it moved 1,000 pulse codes per inch. One thing that it also has to have, it has to have a constant when doing it this method. That constant is, I know from limit switch to limit switch, it's 10 feet. So it's taking that 10 feet as a constant, it's taking how many pulse code counts, and it's basically just doing a divide function. Now it's built that relationship of how many pulse codes it takes to get to an inch, or depending on whatever measurement you're wanting to use. It could be millimeters, and you can change whatever unit of measure you want to measure in. Majority of the time, most Cartesian stuff is done in millimeters. There's sometimes you'll see people do it in inches and whatnot in a standard system, but I've very rarely ever ran across that. And then another thing that's gonna occur with that is the servo, whenever it's running, and it hits one of these limit switches, majority of the time you're gonna say one of those limit switches is your 0 point. So what that does is, if we break out our right hand tool real quick, is it creates a 0 point in your Cartesian world.